Hey, it's Ellsworth again. We have a problem on compound interest. We have two parts here. I only get 5 minutes, so I need to really make it whip. So here we go. There's a problem. How long does it take for an investment to double in value if it's invested at 2% compounded monthly? And then the same thing compounded continuously. Well, let's start with the formula. There's a formula right there. A of t is equal to that business right there. And that's where everything means. How much we invest, P is the principal, R is the rate, as a decimal. I emphasize that because that's where so many students go off the rails. Convert the rate into a decimal. Please. Thank you. N is the number of times per year is compounded. And T is how much time has elapsed since you borrowed the money or invested it, as the case may be. Continuous compounding uses a different formula from this one, and we'll discuss that one later. All right. What do we know? Here's the formula again. A of t is what we start with. We want to know what the amount is at some future time. We know that it is twice what we started with. Our problem asks us to double the amount of money. So we start with P. So doubling the amount is 2P. So A of t is going to be 2P in this problem here. P is our principal. We don't really know how much or care how much we initially invested it because it will not appear in the final answer. So our principal remains some variable P. R is our rate. So as a decimal, R is going to be 0.02. And the number of times per year we compound it monthly. Last I recall, there are 12 months in a year. So it's going to be 12. We're going to compound it 12 times every year. And T is the unknown time we're looking for. So take all of that, put it into our formula. Here's our formula. Put it all in. Divide out the P's. We're left with this. Simplify the thing in exponents. Divide this out. Add 1. You get that. Now here's the fun part. Take the natural log of both sides. You have to get the exponent out of the exponent down to earth. So once you do that, use the properties of exponents. You get that expression. Now the last thing you need to do is divide everything out. That's not a t. And when you do, you're left with this. That's your exact answer. Now put in a calculator. You'll get a result of t is 34.617 years. That's how long it will take any amount of interest, any amount of principal invested at 2% compounded monthly to double. So that's the answer involving logarithms, and this part involving approximations. Now, compound continuously, different formula. You can read what everything equals to here. Put everything in. Twice the principal. Rate is 0.02. Put it all in. There's the formula. Takes a little bit longer. Compound it continuously. But there you go. All right. Hope that made sense. If you have questions, let me know.